Okay, so we continue, huh? So we have the next one is called count. As I mentioned, we use it for count. And the last one is data. Is used basically for I/O operation in addition with the accumulator, and also used with the accumulator for multiplication and division, and also used for string operation. So although all of the four are called data, each one of them have special use. And all of them can be used as an 8-bit, 16-bit, or 32-bit. You must remember this name, huh? AX, AL, EAX, okay, BL, BH. You must remember them because this is how you refer to this register. There is no other way. In high-level language, you don't have register. You only use variable, isn't it? In assembly language, no. Although we can use variable, but we cannot operate on variable. We must move the data in the variable to one of this register before we can perform operation on them. The microprocessor cannot actually perform operation on data in the memory. We have to move it to the register, then we can do operation on it. After that, we send it back to the memory. This happened in high-level language, but is hidden from you by the compiler. If you want to see, actually, you can write your code in C++. You can write a program in C++. Okay? Then you compile it. You will get .exe file, isn't it? Now we can actually, I can show you, we can go to Turbo Debugger. It's a software which we can actually open your compiled file, which is .exe. And you will see, although you never type any of this register, you will see this register exists in your code. It's done by the compiler. So here have to be done by you, because this is what we call level of abstraction. What do you mean by level of abstraction? The hardware sits at the bottom. On top of the hardware, you have machine code, which is lower than assembly language. I will not teach you machine code, because if you learn machine code, you have to correct, all your code will be in hexa. Later on, I will compile this program, and you will see the machine code. And the machine code is what the microprocessor will run. The microprocessor does not even understand your assembly language. If I get the microprocessor there board, which is I can show to you, and you want to program it, you cannot program it in assembly language. You must write your code in hexa, in binary. So writing a code in binary is a nightmare. That's why they develop assembly language. But assembly language is still not that easy, because it is what we call is machine dependent, which means the code you are learning today, the assembly language, it only runs on Intel microprocessor. This is the microprocessor I'm teaching you, the 386. Okay? It can run on the 486, on the Pentium or whatever. It can run on higher version. It cannot run on lower version. That's why your laptop may be 64-bit, but you are running 16-bit code. Although the 386 is 32-bit, I am running it in 16-bit mode. DOS is 16-bit. It's not 32-bit. If you want to program in 32-bit, you must use window programming. Okay, so this is the register. You must remember them, huh? Is that clear? Okay. Not only the name, but what they are used for. So these are the 4 data register. And the next one, another 4 are called index and pointer register. These are only used for addressing the memory. You can see all of them used for memory. Okay? All the 4 of them. So why we need 4 of them? Well, because Intel does not use a flat model like your RISC processor. It uses segmented model, which means it divides the memory into segments, different sections, different blocks. So different blocks are accessed by different register, different pointer register. Why is done like this? This is another philosophy difference between RISC and CISC, between Intel and Apple, for example. Okay? In the old day of PC, memory was very expensive. So if you want to have big program, you pretend you have more memory than you physically have. And it's called virtual memory or logical memory. And that's why it's done like this. The problem with it, you may accidentally overwrite your own data because physically you have limited. So you end up moving data in and out of memory. So it's slower, but the memory appears very large. So we have 4 of them. Each one can or designed for different segments. Like the base pointer is meant for the stack segment. Remember, we have type dot stack. Toward the end of programming, we will learn how we use the stack. At the moment, we are not going to touch it. So if I want to access the stack, I need to use BP. Okay. Another one, SP, also for the stack segment. So stack segment have 2 registers. One is the stack pointer and one is the base pointer. Why? Each one of them operate differently. You study with Dr. Chung about data structure. He teaches you stack, isn't it? And stack operate on very specific principle called last in, first out, which means the last data you put in the stack is the first one you remove it. So here, our stack memory operates exactly like that. And it uses this guy, the stack pointer. So if we want to operate the stack memory as a stack, we use the stack pointer. But if I want to operate the stack memory as random access memory, like normal memory, I need to use the base pointer. So when we reach the lecture was dealing with the stack, I will show you how you use both of them. They are different. Now, these 2, source and destination, they can be used to access the memory, the data segment, but they also can be used to access the extra segment. I will later on come to the segment. We have 6 of them, actually. So If I am using string operation, then SI and DI are fixed. The SI is used for the data segment, DI is used for the extra segment. This is only if I'm using string operation, string command. But if I'm not using string command, I can use SI and DI for any segment which I declare it as a data segment. Okay? So sound a little bit complex? It is complex. If you deal with the hardware, become more complex. So if you are going to, once you graduate and your job is to basically hired by a company which asks you to create a compiler, you need to deal with this. Or if you hired by a company to develop what we call device driver. You don't see device driver. Actually, Windows have something called autoplay, which means it detects what hardware you connect, and it automatically install its device driver. But the device driver, someone has to write it. So the person who write it, he must be familiar with this, with assembly language. Okay, so you remember these four? At the moment, we don't use them because we are not, the code I have given you so far, I did not access the memory. Although I did access the data segment, but I used DOS to do it. So this is the general purpose. Any question about this 8 register? You must remember their name and what they are used for. You cannot forget that. Yes. Okay, microprocessor does not care if it's RAM or ROM. Okay? It can read either of them. The only difference between RAM and ROM is RAM, you can read and write, while ROM, you can only read. But even if you read, you still need the pointer. Okay? The next one is the segment register. These are special purpose, huh? So the general purpose, there's only two. Data, index, pointer. There's only two. For the special purpose, you have 4 of them. Okay? The first one is called the segment register. In the 386 can support up to 6 segments. And these are the segment. These are not actually the segment, these are the segment register. Huh? These are the segment register, SS, CS, DS, ES, GS, and FS. If you remember yesterday, I set up DS. The second line, I said move AX DS, isn't it? And if you look here, DS is the data segment. Why we need like that? As I mentioned earlier, logical address and physical address is different. Logical address always have 2. One we call it the segment, and then the offset. Always the address is like that. So when you write in your code, you must specify both. This one, we don't need we only need it one time. This one for each variable. every time you access the memory, you need to specify the offset. So the segment must be segment register. Okay? The offset is index and the pointer register. So if you noticed yesterday when I read DOS and I show you DOS function number 9, it gives you the address DS, DX. So it gives you both data segment and the DX. Okay? So whenever we address the memory, we need both the segment register and the offset, which is index and the pointer. So if I am reading data, I use the segment register is specified by DS. If I am reading code, the segment is specified by CS, the code segment. If I am reading from my stack, the segment is by SS. Now, if I am dealing with a string operation, then I need DS and ES. So what happened to the GS and FS? These are extra segments. You can use them for code or for data, depending on your model. For this course, we always use small model. Small model, we don't need GS and FS because small model use only 3 segments. But if you use large, compact, or very large, the number of code and data segment will change. The stack segment always 1, will never be more than 1. But the data and the code can. So if my program have a lot of code, but not a lot of data, then I can have more than 1 segment for my code. If my program requires a lot of data, but not too much code, then I can use a model which have 1 code segment and multiple data segments. So you have all 6 data segments. So maximum you can have 6 segments in your program. Each segment is 64K. That's the maximum in DOS. If you are using real model, okay, we are using real mode, which is 16-bit. Therefore, the maximum size of your program and data, the maximum size you can take in the memory is 6 multiplied by 64K, which is around 384K. Now, the next one is called the instruction pointer. Now, you have no access to the instruction pointer. Okay? The instruction pointer is used to access the code. Remember, every address requires 2 things: segment and offset. So my code segment is CS. Okay? But if you look at my pointer here, none of them address the code segment. This one addresses the stack. This one, the extra segment. This one, the data segment. This one, the stack segment. So none of them address actually the code segment. So to access the code segment, you need this guy, the segment register. You have no access to it, which means as a programmer, you cannot change its value directly. You can change its value indirectly by using the jump command. Okay? But when you debug your code, you will see it. Okay. So the next one is the control register. Again, we don't use this one at all. The control register have one purpose. Now, the 8386 operate in two modes. One we call it real mode, other one called protected mode. Now, real mode is exactly like 16-bit microprocessor, except it's faster. Protected mode, no, it operates in 32-bit. Doesn't operate on 8-bit or 16-bit anymore. So if you run it in protected mode, you have to write all your code in 32-bit. But the microprocessor, when it starts, it always starts in real mode, in 16-bit. So you have to use this control register if you want to switch to the protected mode. And that's why we are teaching you the real mode, because it won't start in the protected mode. So you must run in real mode first. And real mode is very much simpler, because you only have a limited number of registers. If you go to protected mode, the register name will change. Okay? Then we have the flag. Actually, there's only one register called the flag. Okay? If you are running in protected mode, it's called E flag. If you run it in real mode, we just call it the flag. Now, in real mode, we have only 9 flags. Okay? In protected mode, there are all the 32 of them. Now, the first 6 is what I call them the status flag. You remember in logic, we use LED to tell us if something on or not. So here the status flag will tell you what's happening within the microprocessor. The first 6. The last 3, no, they are control flag, which means they are like switches. You turn them on and off yourself, which affect how the microprocessor will behave. So we have, although all of them are blank, 6 of them, they tell you what's happening within the microprocessor. The other 3, you can think of them as switches. You turn them on and off. If they are on, they tell the microprocessor something. If they are off, they tell him something else. So the first one is called the carry flag. And this will be 1 if there is a carry. What do you mean by carry? If you are adding 9 plus 5, what do you get? You get actually 4 and the carry of 1. Because the carry goes to the next, go to the 10, isn't it? So this is exactly the same. So in binary, if you are adding, let's say I'm adding 8-bit, another 8-bit, if the most significant bit, 1, for example, you get 0 and the carry of 1. Only the most significant bit. So this 1, where is going to go? It will go inside the carry. Okay? So if the most significant bit during addition or subtraction, it generates the carry, it will go into the carry flag. And you will see there is 1 there. If not, it will be 0. A parity, remember in logic, we learn about odd parity, even parity, isn't it? So this is, if the instruction, the result of any instruction have even number of 1s, then the flag is set. Otherwise, it is reset. So if it's 1, it means even parity. If it's 0, it's odd parity. So just will tell you the number of 1s. Okay? So if I want to use my microprocessor to check uh, the message I sent does have the same parity, I can use this one. I do not have to build the logic circuit. So I can use this. The auxiliary carry is exactly like the carry, except is used for BCD. Remember, BCD is only 4 bit. Okay? While byte is 8 bit. So if I'm using, I'm adding a byte, then the carry will tell me if there is a carry or not. But what happens if I'm using BCD? So if you are using BCD, you can check the auxiliary carry. But the auxiliary carry only tell you if there is carry from the, what we call it, the BCD, which is basically the most significant bit of the 4 bit. Okay? And then we have the 0 flag. Well, 0 is the simplest one. If the result of any instruction is 0, it will be set. If it is not 0, it will be reset. Oh, wait. And then we have the sign flag. Now, this is interesting. Now, let's say if you type 5, let's say I want to do subtraction. 5 minus 7, what do you get? -2. You put minus sign, isn't it? Well, the computer doesn't understand minus. I mean the minus sign. The minus sign is a character. Okay? So in logic, remember we use sign bit, the most significant bit, isn't it? This is your sign bit here. So if the most significant bit is 1, the number is considered negative. If it is the most significant bit is 0, it's considered positive. Now, this guy will tell you if the most significant bit is 1, it will straight away become 1. That's what it will tell you. It doesn't actually display negative sign. Huh? It will just set the flag. It's your job to display the negative sign. And then the last one is called overflow. Now, this overflow only works if you are dealing with what do you call it? Signed number, not unsigned number. Huh? Now, let's say I am adding 2 signed number, which we did it in logic. So sometimes, if I'm using 8-bit, the largest number can be stored in an 8-bit is -1 to 8 to 127. So if your result is outside this range, this flag will be set. Tell you, well, your result is wrong because it's outside the range which can be stored in an 8-bit. If you declare your data as an 8-bit, or you are using 8-bit register. If you are using 16-bit, then it is larger than can be stored in 16-bit. So this is the first 6 of them, and as I mentioned, these are the sticks. Now the last 3 are switches, which you switch them on and off. So you can see the trap flag is used to switch the microprocessor into what we call single-step mode. And I will show you when we do debugging what is single-step mode. Actually, I don't know if they teach you to how to do debugging in C++. Did they teach you how to do debugging? Okay, I don't know how well they teach you C++, but most high-level language actually support debugging, but they do it slightly different. But the only way to do debugging, you need this guy, the trap. So when we switch it on, the microprocessor will go into single-step mode. What do you mean by that? Remember yesterday I typed like move AX segment from, isn't it? So it will execute that one only and it will stop. It will not display, it will not run the whole program. And wait for you to press any key on the keyboard, then do the next step, next one. So this allows you to see what's happening within your program. And this is the essence of debugging. To do that, you need to switch this flag or switch, you have to switch it on. So it is your job. In your code, you can set the trap flag on and off. Okay? In our program, we never use it because we don't develop a debugger. But we will use this one, the direction flag. The interrupt flag, this enable or disable. There is a pin which when we study the hardware, you'll find one pin on the microprocessor called interrupt request, INTR. So this switch can switch that pin on and off. And the last one is direction flag. Direction flag is used when we do what we call it, string operating. We can operate from the beginning of the string toward the end, or from the end to the beginning. So this actually will increment or decrement the SI or DI. Remember, SI, DI are the one used for string operating, the offset. So this will either auto increment or auto decrement this flag. Okay? So this one you must remember that. Okay, any question? Memory management, you read it. And yes.
Register or like
Abbreviation. Okay. Now, the flag, you have, they are status flag. Okay? You can only read their status. How we read their status? There are specific commands. Okay? So you need to understand all the command in the instruction. Remember, yesterday I showed you the instruction set? So that's all the command. You have to go through all that command. This is just when I do turbo debugger, when I do debugging, then I know what C stands for, what P stands for. They just show you their value. You cannot change their value. You can read their value only. How you read it, there are commands for that. The same for setting these switches. Like if I want to set the direction flag, called STD, set direction flag. If I want to clear it, called CLD. So you need to know which instruction actually set or reset that flag or read its value. You have no access to them. The only thing you have access in your code are this. Yes? This one you can specify them in your code because I can decide where my data is, and this one where I want to store it. If you look at our program yesterday, okay, I will go back to the program. Let me finish first this one, okay? Now, the memory management, you just read it for information. And this one I mentioned about flat addressing, segment addressing, and how the physical address is generated. So you read all this one. And although we have 6 segments, and we have, remember, we have 6 segment register, but we have 5 index and pointer register. 4 of them, you have access to them, which is SP, BP, SI, and DI. But one of them you have no access, which is the instruction pointer. So if I want to read code instruction, the default segment is the code segment. And the offset is the instruction pointer. And this one cannot be changed. I mean, this combination is the default. Then, if I want to use a stack, the default segment is the stack segment. I can use the stack pointer with it or the base pointer. But the default is the stack pointer. So the way we use the stack pointer and the base pointer is different. If I want to use the data segment, I want to read data, I can use the BX register, although this is data register, I can use the DX, and I can use SI, I can use DI. Okay? If I'm using string operation, I have to use ES and DS together. And then for the ES is DI, for the DS is SI. And this one cannot be changed if you are using string operation. Now, remember I told you the model? In our program last time, we have dot model, and I use after it small, isn't it? So we have 5 different models. We can have tiny model. If you use tiny, you only have 1 code segment. So it does not have stack segment, it does not have data segment. And tiny model actually will produce what you call it .com, not .exe file. If it's small, it will have 111. If medium, you can have multiple code, but 1 data and 1 stack. You notice the stack always will have only 1. You'll never have more than 1. If I'm using compact, you will only have 1 code segment and multiple data. If you use large, you can have more than 1 code segment, more than 1 data. But this is important. All data are far by default. The other one I will explain what does mean far and near. I mean, at the moment, it doesn't make much difference for you. We will never use large anyway. But I will explain what is far. So that's the end of this lecture. You can do the exercise now. Okay? Any question? Anyone have a question? You need to read this one and remember it. Huh? Any question? No?
Doctor,
Yes?
can you show how to use the
I cannot hear.
can you show how to use the flags
Uh,
in the code?
you cannot use the flag as I mentioned. The flag, if you want to use them, we need up to lecture number 4. I will show you how to use the flag. We use the flag for program control. So when we learn how to use what we call, remember in high level language, you learn how to make loop, like for next loop, while loop, and you learn to use if and case, isn't it?
Yes.
When we want to use that in assembly language, then we need to use the flag. Okay? And I will show you the command for looking at the status of the flag. I mean, looking at the status of the flag, basically you decide to either execute a certain command or not. For example, if the flag, the S flag is 0, what to do? If it's 1, what to do? So to do that, you need if. And that's what we are going to learn around lecture number 4. Okay? Now, all what you have to remember is the flags. Their name, what they mean. Okay?
Okay, Doctor. Thank you.
Hmm? Abbreviation. There is already. You can see the C, whatever. This is the abbreviation, isn't it? That? What abbreviation you want? Oh, when I use turbo debugger, you will see CPA, so you understand what they are. Okay, let me show you anyway. Let's go back.
So they use for comments. Or so they use for comments.
Not for comment, no. Why I cannot see this guy? Yes.
Essentially, we need to memorize the signal.
Sorry?
So we essentially need to memorize the signal.
The segment address, yes, you need to know what are the registers for each segment. Okay? This is very important. Remember yesterday I used DS because I want to refer to my data. CS, you don't need it because CS IP is by default. You only need to put the .code. The stack, you define the stack segment. If you don't have stack segment, you cannot use the stack. Okay? Code segment, you cannot have a program with no code. So every single program must have a code. Okay? But I can have a program which have no data, no segment. Remember the tiny? But every program must have at least one code segment. I think, let me see why I cannot get this one. I'm trying to share with you what we have done yesterday. Now I can see it. Can you see the code? Can you see what the program we have done yesterday? Okay, so
Yes.
so you can see how I set up the data segment, huh? Now, why I use, let me make a mistake. Remember here I type AX, isn't it? AX 16-bit, DS is 16-bit. So if I type here AH, okay? AH is 8-bit, while the segment is 16-bit. So if I compile this one now, let me try to run it. Can you see? The code assemble process failed with error. So you go up, scroll up, you can see the error. Okay? You can see the assembling file welcome.asm, move AH segment message, error, welcome.asm, number 9, which means the line number number 9. Okay? Not expecting group or segment quantity. Sometimes the error message is cryptic. You don't understand what it actually means. So what it means actually, this is an 8-bit. The segment address is always 16-bit in real mode. Okay? Is that clear? So if you make syntax error, like in C++, you won't compile. Your program will not compile. Assembler is a compiler. Okay? Is that clear? So let me now, I'm going to change it. I can use BX. BX is 16-bit. Okay? Not necessarily I use the AX. Now it will assemble, but it won't run. Can you see what I got? What do you got? Rubbish, isn't it? Garbage. You type VX. Can you see? What do you get? Let me show you my entire screen. You get rubbish. Right? Why I'm getting like this? Okay, I don't know why it doesn't do it. Okay. So if you get the rubbish, so what to do with it? You should get something like this. That's what you get, isn't it? Why we get like this? No, it's not the problem yesterday, huh? Yesterday, the problem was the dollar sign, isn't it? But now the dollar sign is there. Now the problem is here. Remember, I put the segment in BX. Okay, but here I put AX. So basically, what happened is that I did not set the data segment. The data segment will never be empty. I mean, any register will never be empty. It will always have value. But the value is not pointing to the right place where I declare my variable. So let's see if I put BX here. Okay? Now we're running. It won't. Okay? So, because BX and AX both general purpose register. So for certain application, you can actually replace one. Like DOS function number, when I call DOS function, the function call will always be in AH, nothing else. So now if I change this one to this one, remember, I've said move AH 9, isn't it? Now let me change it to AL. It's another register, okay? Another accumulator. But the DOS function requires the function to be in AH, not in AL. So I don't know what is in AH. So you may get something unexpected. Because the DOS function number 9, I mean, here, AH we don't know. So when the interrupt here is executed, he will look what is inside AH and will execute that. Imagine that me and you are communicating through him. Okay? So when you tell me do something, I will ask him what he has. So we have one pigeon box to communicate. You put there inside that pigeon box what I'm supposed to do. So you put it in the pigeon box with AH, I read it from AH. Okay? So DOS interrupt 21 always read whatever in AH. So if you don't put anything there, whatever left, whoever put there, I will read it. And now let's see what happens. I have no idea what will happen. But most probably is not going to display the message. Okay? Nothing happened. It all depends what is in AH. And no, notice the program hang. Normally you press enter, you should go back, isn't it? No, press enter, it doesn't do anything. The program hang, doesn't know what to do. So you have to close it. Okay? Now let's put it back. And you will see it will work correctly. So you need to understand how the communication works between DOS and your code. So interrupt 21H, always read AH. Now it may require different parameter in different place. Like DOS function number 9 require AH to be 9 and require this is DX, the offset, isn't it? What happens if I actually put DX here? Now DX is pointing we don't know to what. So you are going to get garbage again. Okay? You get garbage again. right? Is not actually rubbish. This is actually the content of the memory where the DX register point to. The memory inside your computer will never be empty. So it reads until it finds the dollar sign, then it will stop. The DOS function have no idea where to begin. So it or where to stop. It depends on DX tell her where to begin. Okay? So DX tell her, okay, start from here. So it starts from here, start reading everything until it finds dollar sign, then it will stop. Okay? Is it clear? If I put dollar sign at the beginning of my message, it won't display the message, huh? So we need to put DX because this one requires DX. Let's run it again. Now it will work. Okay? Welcome to assembly language, isn't it? Are you following me?
Yes.
You practice what I am doing, huh? Don't just watch. So let's see now, if I put dollar sign here before the welcome, huh? Put dollar sign here. And let's see what happens. Nothing displayed, right? But the program did not crash, huh? You press the enter, it go back. Remove it, it will work. Okay? Any question? Any question? Anyone have a question? Anything you don't understand? You want me to explain?
So, doctor,
Yes.
if I put the dollar sign after welcome, it will only show welcome.
Yes. Whenever it finds the dollar sign, it will stop.
Okay.
Now, suppose I want to, this one only display one line, isn't it? Welcome to assembly language. Suppose I want to display after it lecture 2. Okay? So I have to add another variable. I could put it here, but I suppose I want to display it on the next line. I can do message 2, I can do mess 2, DB again, lecture 2. And then you put the dollar sign, okay? This will not display, huh? So in order to display it, I need to do it here. After I display the first message, I need to repeat these two commands. These two. Except I change the offset to mass 2. Okay? You follow? It's like typing in high-level language 2 print command. The first one print message, and the second one print mass 2. Okay? You run it, let's see what happens. You get them on the same line. You get them on the same line, isn't it? What happens if I want lecture 2 on the next line? What do you do in high-level language, in C++?
The slash
Slash what?
C
Slash n, isn't it?
slash M.
Okay. If you remember in your logic, we learned about the ASCII code. Okay? And I told you in ASCII code there are some code which we call them control code. One of them is called the enter key, which is basically, and one is line feed. So 10 and 13. So if I want this one to be printed on the next line, I can put this code before it. 10, 13, like this. So this is like slash n before lecture 2. Make sure you separate them with comma. Huh? Then you run it and let's see. Is it on the second line? Right? Okay. I can actually, let's try to put 13 here, 13, 10 here, okay? However, remember this will stop when the dollar sign is. Okay? So let me see if I put it here. Will it go down or not? So I remove this one from here. Okay, I put them here. But I have to put comma here. And let's see what happened. It did not do it, isn't it? Because basically the dollar sign, when it reaches, it will stop whatever after it. Let's remove the dollar sign from here. Okay. And put it here. And let's see what happens. Are you following?
Yes.
Did it work? Okay. Did not work? Always you separate variable with comma. Okay. Now, let's try to do it, to put it inside here. So actually, I'm going to remove all this. You don't need the comma here because part become part of the text. Let's see it will work or not. Okay? It did not work. It typed 1013, huh? Because it takes 1013 as a text. Okay? Not a number. There is a difference between 1013 as a string because it becomes 1 and 3, while 1013 is hexadecimal number. Okay? So if you put them outside the quotation, it works. Inside the quotation, they become a string. No more a code, no more a number, huh? But I can put them, as I mentioned, either after it here or below this one, before this one. So I can put either here or I can put them here. Okay? There's two ways you can do it. Any questions so far? Any question? Anyone have a question? Anything you don't understand? Anyone have a question? No? Okay. So I will show you something where you can see the register and the flag and so on. Now, in order to see them, you click this guy here. Debug the executable. If you click it, you should get this, right? So this is your code. This is actually another program. It's called Turbo Debugger. GUI is actually just an interface which put this one together. I could run my assembly language without using GUI, but I need to have 3 different software, actually 4. I need an assembler, which is called turbo assembler, TAS. I need the linker, which is called T-link. I need a debugger, which is called TD, turbo debugger. And I need a DOS emulator because I'm running on Windows. It's called DOS box. So you need all these four. And that's what I used to do before. Then I discovered this GUI. So this one have put them all together. So I don't need, I can run them from this interface. But you need to understand this turbo debugger. Now we are actually out of the GUI. So you can see here you have a menu. Now you are no more in Windows, huh? We are running DOS. So you will notice after a while your mouse doesn't work. Initially it works, after that it doesn't because you are running in DOS. So up there you have a menu. So if you want to access the menu, you press the alternate key and the red letter. Huh? So if I want to open file, I press alternate F. This computer is not working, I don't know. Okay. And then you have the edit menu, view, run, breakpoint. So basically, data and window and option and help. So basically, this is a program which allow you to run your code in single mode. If you notice here, you can see there is little triangle. Can you see this little triangle? This is actually where is your instruction pointer, which means now we are exactly at this command. Okay? And then if I want to run, you can see the one command say step. Can you see F8 step? Right? So if I press F8, this instruction will be executed. So I press F8, you can see it goes down. Isn't it? But you don't see the result. I can click view and register. You should see the register. Can you see the register? Click view and register. Huh? View and then register. You can see your CPU if you want. CPU will show you everything, huh? Can you see here the flag? Can you see the flag? C, Z, S, 0, I mean O, P, and then A, I, D. You don't see the T flag, huh? I is interrupt. D is direction. There's one missing, which is the trap flag. Huh? Can you see the register AX, BX, CX, DX, all of them? And you see IP, the instruction pointer. Now the instruction pointer is say 3. Because the first instruction actually takes 3 bytes. You can see it here. CS003, and then you can see the little arrow and pointing the next instruction, which said move DSPX. This is assembly language. But in machine code, it looked like this. 8EDB, which means if I want to write program without the assembler, okay, I want to program directly the microprocessor, I need to write 8EDB. So this is the code which is the microprocessor will execute. But this is what we type in assembly language, move DSPX. So if now let's look at what's the value of BX. Can you see it? 087E, isn't it? What's the value of DS? 086C, so it's different. So if I press F8 now, that instruction have been executed. Now my IP go to 05. Notice the DS have changed to exactly like what BX. So move, actually it copied the data inside the BX register, move it into DX. Okay? Any question? If you notice down here now, it used to be DS, now changed to ES. It used to be DS, now it's ES. So if I want to see my data segment, I can go view and dump. And this is my data segment. And you should be able to see, welcome to assembly language. Can you see it? Welcome to assembly language. And this is the address, DS, then 000. So the offset here is 000. Okay? So my offset for the first message is 000. So notice later on, when I execute the command move DX offset message, it will put actually this number, 000. And if I go down a bit, I should be able to see the next one, lecture 2. Okay? Lecture 2 will start at 0020. I can close this one, just click the arrow down, it will close it. Okay. So now I execute this one, F8. Notice that AH becomes 09. When I said move AH, only change the AH. It does not change the AL. So AH is the one on the left-hand side. AL is on the right-hand side. And notice how here it said move DX 000. I did not type that. I typed move DX offset message. So the assembler actually changed. He get the where's the message stored and give the change it with its value. So when you actually write code in the microprocessor, you cannot use variable. You must use physical memory address. And that's the physical memory address. And you can see this one have been changed to move DX001E. Okay? So if I run it, now you can see DX have changed to 000. And if I execute the interrupt 21H, it actually displays a message, but you cannot see it. So if you want to see it, you go to Window and User Screen. And you should see the word Welcome to Assembly Language. Are you following me? If I press Enter key, we'll go back. And now the next message, move the X, the address 001E. So you notice that this value will be put in DX. Now DX is 00, it will change to this value. And I execute interrupt 21H, press F8. Now the second message is displayed. Window. Now my mouse doesn't want to work. Alternate W. Then you can see lecture 2. Enter, I go back. Now, notice my code finish here. But after my code, there's still plenty of things inside the memory. The memory will never be empty. Okay? So if you don't put end star to tell the microprocessor, the assembler, where to stop, it will keep reading the code segment. So if I press it, you can see it's 4C. If I press F8, it will say terminated exit code 0. Actually, this exit code is what was in AL. Then done. If I want to finish from this guy, alternate file, then quit. Any question? Turbo debugger is very useful if you want to find out why your program does not work as intended.
So, doctor, if the line of code is not working, will not like problem going on.
Sorry?
If there's like a line of code, it's not, there is error on that line of code, it will not like, store the memory for it.
No. It depends what type of error. basically two main type of error. One, we call it syntax error, and the other one is called logical error. But unfortunately, logical error, if you go to ChatGPT and ask him software error, it will give you around 20 of them. But all of them are logical, different form of logical error. Why they give them different name depending on when they occur. Okay. Syntax error, your compiler will detect it. Remember when I put here move AL, here I put move AH segment message or AL. So syntax error occur when you break the rule of the language you are using. For example, here I'm using assembly language. If I use an instruction which does not exist in the instruction set, or I use directive which is not in the turbo assembler directive, then it will get me syntax error. And it will tell you that. It will not compile or assemble your program. It will tell you assembly language failed, error number, whatever. Let me give you an example. If I remove here the dot in front of data, there is no such directive in turbo assembler. Huh? So if I assemble it now, it says assemble process failed with error, isn't it? And you go up, you will see all the error, huh? So many errors. Because I did not declare the data segment, so it doesn't understand what is message, what is mess. Okay? So this is what we call them syntax error. The assembler detect them for you. Okay? Now let me put back data. And now let me put here, rather than BX, is AX. Okay? Okay? And now if I run, I will get no syntax error, huh? I will get no syntax error. The program ran. But does not give me the result I want. What I'm expected. I'm expecting to see the word welcome to assembly language. Isn't it? It's not that. So how do I know what's the problem? Now I can go to Turbo Debugger and find out what. Okay? But in order for you to make use of Turbo Debugger, you need to understand what is the value supposed to be in each register. Which means you need to understand what each instruction is supposed to do. If you don't, it doesn't make sense to you. You won't understand what's going on. You won't find the problem. So you need to understand every single command you put there, what that command does, where it's supposed to get its input from. Okay? So I'm using DOS function number 9. I have to read DOS function number 9. It says DSDX, but I did not set up the DS properly. And if you look in Turbo Debugger, I can show you why DS is not set up. Okay? So I'll go View and CPU. Okay? Now you are not seeing on the one on the online, and now my mouse doesn't want to work. So I cannot show you because the mouse is not functioning now. I don't know why it doesn't go out. I will share my entire screen. Let's see why it says like that. Okay, now you can see it. So if I go to view and CPU and I run the first two lines, this line, okay? So if you notice here, I set up BX. Now this is DS. I expected this one to change. And when this one changes, this will change. Notice here you have DS. When I set up DS, this will change to ES. Okay? DS changed, but changed to 000. Why? Because AX was 000. Okay? It did not follow, although this one changed, okay? But this was not pointing to where my data is. If now I go to view and look at my dump, I don't see my message. You should see here, welcome. I don't see it because it's the wrong place in memory. Okay? I don't see welcome. So it won't display. It will display something, but it won't display welcome because the memory is never empty. Okay? So you know where the problem is. So you go back from here. Once I find the error, I close it and I go change it. And then run again. If it works, then the error is fixed. If not, you go back again and find what's the problem. We will use it most of the time. Okay? It's very rare to write a program where you don't make mistake. I have been teaching assembly language probably before you were born, but still make mistake. Any question?
No, doctor.
Okay, so let me take the kahadiran. Now for next week, you read chapter 1, 2, and 3, huh? We already covered chapter 1 and 2. You read chapter 3, which is that the movement. That's what I will teach you next week. Okay, kehadiran.
Doctor,
Yes,
I'm still not registered for the course.
you have to register. I cannot do anything about that.
Yeah, tomorrow is the registration date.
Okay. So you register. The first week, I will not, because normally you can add drop the first 2 weeks, isn't it?
Yes.
So the first 2 weeks, I will not count the attendance.
Okay. Thank you.
But for next week, I need to do the grouping, huh? The class representative, make sure you send me the grouping, huh?
Okay.
You send it to the group WhatsApp, huh?
Okay, doctor.
Okay, so if you have signed, you can go home, and next Monday is declared as a holiday, isn't it? But your class is on Tuesday. So I will see you on Tuesday, and Salamat Hari Raya for those celebrating, and happy holiday for those who are not celebrating.
Thank you, doctor.
Okay, bye-bye.